The purpose of this video is to provide initial context settings and guidance for running Proteinaceous samples. The context menu establishes the settings used by the FlowCam to capture particles of interest during sample acquisition or during file processing analysis. These settings can be modified depending on your sample to achieve optimal particle imaging and analysis. Context settings are stored in a separate file with the CTX file extension within the folder containing all the files for a sample run, or as a file that can be stored within the Documents, Visual Spreadsheet Context folder. You can always restore your factory default context settings from the Load tab within your context menu. In this video, we'll show you how to set up your context menu so that you can acquire data for a typical protein sample. Some of the context menus may need to be adjusted depending on your sample type. This training video will establish initial context settings. You can find more information and definitions on context menus in your manual. Launch Visual Spreadsheet and select Context. Proceed to the Capture tab. Under Particle Capture, choose the following settings. Set distance to nearest neighbor to 2 microns and closed hole iterations to 2. Keep in mind you can increase or decrease the distance to nearest neighbor and the closed hole values. The lower the value you select for distance to nearest neighbor will separate particles that are close to one another better. If a sample is very concentrated, a high distance to nearest neighbor may result in multiple particles captured in one image. Under Images, select Collage Image Border Padding to 4 pixels. Make sure to select Save Collage Images and Save Binary Collage Images. Select Save Raw Camera Images if you intend to use file processing mode. Otherwise, keep this option deselected. There is a separate video to explain file processing mode. Proteinaceous particles tend to be more translucent than sizing beads. Therefore, under Particles Defined By, choose both dark and light pixels and set both dark and light pixels to 17. This setting determines how the camera delineates the imaged object from the background. After you run a sample, if you notice that the particle edge trace requires optimization, you can either increase or decrease the segmentation threshold values. The acceptable region establishes the camera view and can be modified to lie within the flow cells channel when setup and focus is used. The steps for adjusting the acceptable region is covered in the training video, How to Install and Remove a Field of View Flow Cell. Rolling calibration is a newer feature available, and it's useful when particles get stuck in the flow channel and won't be imaged repeatedly. Selecting this value automatically establishes a continuous overlay of 10 sequential frames to compose the calibration image. This is repeated throughout the sample run. If you want to select this value and change the number of continuous frames that are used in the calibration image, select Shift key and left mouse click over Enable, and a hidden menu is displayed. You can increase or decrease the frame count. You can choose to select or not select this setting. Fluidics is the next context menu item that should be evaluated when setting up your context settings. Under Settings, enter your sample volume, the flow rate, and auto image rate. Depending on the values you select, estimated efficiency and run times will automatically populate. An automatic message will appear when the efficiency is 70%. This is simply an alert and can be ignored if you want to increase your efficiency above 70%. The efficiency is a numerical value that gives the ratio between the sample volume imaged versus the sample volume processed by the camera. To determine whether the efficiency is too high, you must evaluate the images captured. If the same particle is captured multiple times, then you may want to increase or decrease the flow rate. Multi-imaging means that the efficiency is set too high for the type of sample that is being analyzed. A good starting point for the flow rate is 0.15 mils per minute and 30 frames per second at 10x objective. The factory defaults provide a starting point for selecting the flow rate and frame rate for each objective. Keep in mind you can increase or decrease the flow rate and frame rate, and the optimal settings will be determined by your sample type. You can always restore the factory default settings by navigating to the Load tab and selecting the factory default settings. Make use of the fluid position sensor by selecting the Machine Prime option. If you want to manually draw a sample into the flow cell when using the Setup and Focus and Pump controller, then choose Manual Prime with Sample, and data acquisition will begin immediately after you initiate the sample run. The Filter tab allows you to eliminate data from the acquisition of your data. You can set a diameter range using ESD or ABD, or you can choose no size filter if you want to collect all particles. Setting a minimum size value above a specified diameter allows you to eliminate any images that are less than the resolution of the objective installed. For example, at 10x, the minimum diameter is 2 microns. 4x is 5 microns, and 20x is 900 nanometers. Any image with a diameter less than these values is too blurry to accurately size. In addition to the basic size acquisition filters, there is the advanced acquisition filter option. You can select any additional particle property ranges. For example, you can select the particle property circle fit with the criteria 0.7 to 1.0, and therefore only circular particles would appear in your image collage. This might be an option you would select if you are interested in capturing silicon oil droplets or sizing beads. The tabs Flow Cell Reports and Stop Conditions are self-explanatory based on your configuration and preferences. You can save these context settings by clicking the Load tab. You can choose to save these context settings as the local default, or you can save context file as, where you can give the context file a name. We recommend that you name your context file with the description that includes the objective and flow cell type. For example, 10x FOV100 context. Save the file in the Documents Visual Spreadsheet Context File pathway so that you can easily find the context file again. You can also load these settings and other saved settings at any time by selecting Load a Context File. Select OK, then proceed acquiring data by selecting Auto Image.